Moving into our next unit, we're going to start talking about triangles. And so I kind of combined a couple of sections into one section here, mainly just because they kind of all fit together really well. It does cause for a lot of vocab, but that's geometry. So what we're going to do is identify and classify triangles by angle measures and side measures. We're going to find the missing angle measures in triangles, and then we're also going to use properties of isosceles and equilateral triangles to find some missing measurements in there. So what I want you to do is, on your index cards, you're going to do all of these vocab words. And I've split them up exactly the way I want them to look. And so actually, this needs to be kind of scooted over a little. Okay, so first we have acute triangle. And that's a triangle with all acute angles. And we use it when we're classifying a triangle by its angles. And so these would be examples of acute triangles. And actually, now that I'm looking at this one is not acute. This one would need to be more like that. No, it still looks like it's more than 90, doesn't it? All right, well, make it look acute in your picture, I guess. All right, moving on. So equiangular. So this one is a triangle with all congruent angles. And so we call this one, again, this is classifying by angles, and you need to make in your figure show that all three angles are congruent. So all of them have to be congruent in order for them to be equiangular. All right, the next one would be an obtuse triangle. Go ahead and slide that over. An obtuse triangle is any triangle that has one obtuse angle, just one, that's it. So again, we use it to classify our triangle by angles. And then we have right triangle. So in a right triangle, this is where we have one right angle. So you see the right angle here, and we use it to classify, again, by its angles. So far, we've talked about four types: acute, obtuse, equiangular, and right. And all four of those are classifying by its angles. All right, now we're going to classify by sides. So when you are classifying by sides, oops, let's try this again. When you are classifying by sides, the first type is called equilateral. So equilateral, and you'll notice it has all three sides marked as congruent, and it's when all sides are congruent. And so this is a classification by sides now. All right, our next one is isosceles. So in an isosceles triangle, we have two congruent sides and two congruent angles. Now, we use isosceles when we are classifying by sides. So I marked the two congruent sides here in this triangle. We have scalene, and in a scalene triangle, none of the sides are congruent, and you'll notice that in the picture, all three are marked differently. So again, this is still a classification by sides. And then so those are your side classifications. So we only had, what, three of them? We had equilateral, isosceles, and scalene. All right, now we move into the triangle sum theorem. And so basically all this is saying is if you have three angles in a triangle, they're going to add up to 180 degrees every time. And so the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 every time. And now this is the angles, remember, not the sides, because side lengths vary. So now we have what's called a corollary. And a corollary means that it kind of is based on the original statement that all three angles add up to 180 degrees. But this one is specific to right triangles. And so what's kind of nice is that the two acute angles in a right triangle add up to 90 degrees. So the reason I want you to know this is because it makes it a lot easier on yourself. Because if you have the measure of angle 1 plus the measure of angle 2 plus this 90-degree angle equal to 180, well, what happens when you subtract the 90 from both sides? You end up getting that 1 and 2 together are 90. So it saves you a lot of time in finding missing angles because you don't have to do 180 minus 90 minus one of the angles. You can just look at the two acute angles. And so it was only working for right triangles. Now, a second corollary goes along with the fact that in a triangle, you can only have one obtuse or one right angle in a triangle. You cannot have any more than that. So if you have an obtuse angle, the other two are automatically acute. And if you have a right angle, the other two are automatically acute as well. And these are things that really come in handy for you as we're working through these triangles, things that you need to know. Okay, now the legs of an isosceles triangle. I'm sorry I have to keep moving these. It's really frustrating. But so the legs of an isosceles triangle are your two congruent sides. So in this figure right here, AB and AC would be called your legs of triangle ABC. And you'll see that we use this triangle symbol actually to call the triangle a triangle without having to write out the word completely. All right, then we have what's called our base angle, or our base. And so our base is not always what most people think of when they think of base. They tend to think of the base being the bottom. Well, it's not always the bottom. It's whatever side is not congruent to the other two. So in this case, BC is the base. Now you notice that that wouldn't be what you would typically think of as the base, because a lot of people assume that it's the one it's sitting on, but it doesn't matter. It has to be the one that's not congruent. All right, and then we have our vertex angle. So the vertex angle is the angle that's formed by the two congruent sides. And in this case, that would be angle BAC. So this angle right up here is your vertex angle. And if you want, you could even mark it in your picture to show that that is your vertex angle right there. All right, then we have, of course, because we have a base and we have a vertex angle, we also have base angles. And so the base angles are the two angles in an isosceles triangle that are congruent. So BCA, which would be this right here, with CBA, which would be this angle right here. So those two are congruent. Those are your base angles. Now you'll also notice that the congruent angles are directly across from the congruent sides, which is something to kind of keep in mind, the further we get into this unit. But those are your base angles. Okay, so now that we're done with the vocab, we're going to move into some examples. So this example right here says to find x and then to find all three sides of the triangle. Okay, well, how do we know what to do? Well, if we're looking at this picture, based on the way that it's labeled, triangle ABC is isosceles. So since it's isosceles and we have our congruent sides here and here, we can set those two equal to each other. So 4x plus 1 equals 5x minus 0.5. So we would add 0.5 to both sides of our equation to get 4x plus 1.5 equals 5x, and then subtract 4x from both sides of our equation here to get 1.5 is x. All right, so our x value is 1.5. So then what we do is we plug that into the equation to find out what exactly is AC, BC, and AB. So AC, AB, and BC. Well, since these two sides are congruent, we don't really need to plug the 1.5 into both places, but I will just to kind of show you how it works out. So 4 times 1.5 plus 1. That comes out to 6 plus 1, which is 7. So AC comes out to 7. Now, if we did this correctly and we have the correct x value, BC should also come out to 7. So 5 times 1.5 minus 0.5. Well, 5 times 1.5 is 7.5, and if we subtract 0.5 from that, we get 7. So it did come out as 7, so we know that we have this correct. And then with 9, we're plugging in 1.5, and then we're subtracting 1 from it. So 9 times 0.5 is 13.5, and we're subtracting 1, giving us 12.5. So 12.5 is our third side length. Okay, now, and if you want to, you could even go through and label this AC, AB, and, nope, I'm sorry, not AB. I knew I had that wrong. BC and AB right there. Okay, so that's one example, and that's using isosceles triangles. So now that we have one that's equilateral, well, equilateral means all sides are congruent. So we can take any two, it doesn't matter, but any two you want and set them equal to one another and solve. So just pick any combination, whatever you want to do, and solve it. So I'll do 2y plus 5 equals 3y minus 3. So I'm going to subtract the 2y from both sides of our equation to get 5 equals y minus 3. Add 3 to both sides, so we get 8 equals y. So if we solve this correctly, then when we plug 8 in, we'll get the same number on all three sides. So if we plug in 8 here, we get 16 plus 5, which is 21. So we should get the same thing here. Well, we get 24 minus 3, which is 21. And here we get 40 minus 19, which is 21. So we checked to make sure that we got everything right. So one side length, let's say GF, is equal to 21. And that's how you would do that one. And now you'll notice too, let's say I wanted to take the other two, take 2y plus 5 and set it equal to 5y minus 19. You will still get that y equals 8 because they're all the same measurement. So it doesn't matter what two you choose to work with. All right, now in this example, we're going to find all of our missing angles. And so we're going to kind of work our way around. We have 4, 5, 6, 7, 8, and 9. So one thing that we have to use as we're looking at this triangle right here, triangle YXZ, is that there's 180 degrees in a triangle. So we need to take 58 and add 65 to it, which gives us a total of 123. All right, so this angle needs to be 180. So to find angle 7, we do 180 minus 123, which is 57 degrees. So angle 7 is 57 degrees. All right, now moving along, 7 and 5 are vertical angles. So angle 5 is congruent to angle 7 because they're vertical. So that would make angle 5 also 57 degrees. Now angle 6, so the measure of angle 6 plus the measure of angle 7 is 180, and that's because they are a linear pair. So because they are a linear pair, we take 180 and we subtract 57 from it, which gives us 123 degrees. So angle 6 is 123. Now 8 and 9 are marked with a congruent symbol. So since 8 and 9 are congruent, what we're going to do is we're going to take 180 degrees total, and we're going to subtract our 123 from it, which gives us 57. Okay, but since the measure of angle 8 equals the measure of angle 9, and we need them to be 57 together, the measure of angle 8 plus the measure of angle 9 is 57. We're going to take 57 and divide that by 2, which would give us 28.5. So angle 8 is 28.5 and angle 9 is 28.5. Okay, and then let me go ahead and erase some of this stuff. As we work into angle 4, that one is just using the triangle sum theorem to say that all three angles in a triangle add up to 180 degrees. So since angle 5 is 57 and angle 6 is 67, we add those together for a total of 124. So to get the measure of angle 4, we take 180 and we subtract 124 from it, which would be 56 degrees. And so angle 4 would be 56 degrees. So there we go. We worked our way around the whole figure, starting with the easiest and kind of using the relationships and things that we know to get to the end. All right, and then our last one. So this one is using the idea that if this is a 90-degree angle, then this angle plus this angle has to be 90 degrees. And so it saves you a lot of time to just set these equal to 90 because you end up with 3x equals 90, divide by 3, and you get x is 30. So if x is 30, plug that in, that makes this a 60-degree angle and this a 30-degree angle. All right, so make sure you have all that written down and come in with any questions.